Okay, so here is my X-ray circuit. Let's start with my glossary. So here are the 10 items that we'll be discussing. The circuit, main circuit breaker, the exposure switch, the auto transformer, the timer circuit, the high voltage step-up transformer, the rectification circuit, the filament circuit, the filament step-down transformer, and the X-ray tube, and the rotor and stator, which rotates the anode. So those are the 10 components. And I've actually labeled each one. And what I will do is go over each item and talk a little bit about why I selected the household item to represent each of the components. So the first one is the main breaker. And the main breaker controls incoming current and protects the equipment. And so I chose a garage door opener because I use a garage door opener every day. And it's an example of something that controls something else. And think about it. If it's snowy outside, or if there's rain or ice and your garage door is shut frozen, you can't get in or out. And if you have a car, it's the main entry. It controls your entering your home. So just like a main breaker, the garage door opener controls the entry of something. Number two, that is my exposure switch. And the exposure switch is a two-stage switch that activates the rotating anode. And I chose a key because a key is also an example of something that activates something else. If you insert a key into a door, it first activates the lock by binding with the cut of the key. That's the first step. And then the turning of the key then opens the door. So a key symbolizes the two-step process that's necessary to activate something such as a rotating anode. My third component is the auto transformer. And I chose a step meter to represent my auto transformer. So an auto transformer controls the KDP selection and permits the selection of actually a predetermined voltage, or KDP. Now, a step meter actually does the same thing. I can select 23 steps as a goal that I want to reach on a given day, press a button, and the meter will beep when I've reached that goal. So it allows me to preset something, which is what we need when we're using an auto transformer. It has to have the ability to have a predetermined voltage. Okay, and then number 4 is my timer. And a timer on an X-ray tube circuit terminates the exposure. So it's located between the auto transformer and the high voltage step-up transformer on the primary side of the low voltage part of the circuit. And I picked an hourglass to represent a timer because it's been around since the 14th century, and it's represented a dependable and accurate measure of time. Number 5 is the step-up transformer. And the step-up transformer steps up or increases the power and changes the electricity from volts to kilovolts, and then uses mutual induction, which occurs with the two coils that are wrapped around the step-up transformer. And this is also the transition point from the low voltage primary side to the high voltage secondary side. I chose Red Bull because Red Bull gives you a boost or steps up your energy and keeps you productive all day. So that is my step-up transformer. Number 6 is the rectification circuit. The rectification circuit converts alternating current to pulsating direct current for the X-ray production process. And I chose an LED light bulb as an example because LED light bulbs are direct current devices. They're driven by direct current voltage sources using a current that actually regulates the voltage and the current delivered to the light. So good representation kind of uses similar components to manage the direct current, which is necessary for the X-ray tube and also necessary for the LED light. Okay, my next item, number 7, now we're in the filament circuit. And remember, the purpose of the filament circuit is to modify the incoming line so that there's thermiotic emission in the wire of the filament. So number 7 is my variable resistor, and the MA variable resistor selects the filament current. Just a twist of a knob permits the voltage and the amperage regulation. So I chose a knob from my oven. And if you think about it, when you turn a knob on a stove, it actually sets the amount of electrons needed to heat the oven. It doesn't actually select the heat, it selects the amount of electrons. And so I thought that would be a good analogy for a variable resistor. Number 8 is my filament step-down transformer. And the filament step-down transformer steps the incoming voltage down to heat the X-ray tube filament. And I chose Grey Goose because it's a delicate spirit. It's filtered through champagne limestone. It's distilled from French wheat. It's kind of has an unparalleled smoothness for relaxation and kind of a mellow taste, great for after work energy transformation, and it relaxes you. So that is my filament step down transformer. Number 9 is my X-ray tube. And so the X-ray tube obviously creates the X-ray beam. It allows the electrical production of an image. And I chose a Logitech laser pointer. And the pointer actually is a wireless device that helps you navigate through a slideshow image, and it kind of intuitively highlights specific points and details with its laser beam. So it's something that produces a laser beam. And then my last component, if you can get this here, is my rotor and stator. And I chose to use a pizza cutter. So the rotor And the stator of the anode, it allows the anode to rotate in order to prevent it from melting due to the high heat in the envelope. And then the stator brakes the rotor safely through harmonic range. So I chose a pizza cutter because a pizza cutter rotates evenly across a hot pizza and divides pieces or slices evenly. So here is another view of my X-ray circuit board. Okay, hope you enjoyed it. Thanks for listening.